Okay, so let's start today's webinar. And today we have Dr. Satoru Nakajo from Mitsubishi Research Institute, and he will be presenting. He will be talking about automated driving systems and dynamic map. And this title is a little bit different from what we posted on the webinar site. So anyway, this will be a very interesting topic today and a little bit different from our previous webinar, which is basically focused on the mainly on GNSS. So we'll see how GNSS can be used for automated driving and what are the things that are required. And he will talk more on the dynamic map. So let's invite Dr. Nakazo. So may we request Dr. Nakazo to proceed for your presentation?
Yeah, thank you very
Yes,
much.
please.
Yeah, thank you very much for the introduction. Yeah, as Dean Sensei told, my field is a little bit different from GNSS. I mainly work for the automated driving system and the digital map for that system. So I will present the present situation of Japan and also for the international relationship. And after that, at the final of this presentation, I'd like to say something to the expectation for GNSS. So this is the contents of this presentation. First, I'd like to make a little bit self-introduction. And after that, the purpose of this presentation and activity of SIP ADAS Japan. And the next one, I will explain the dynamic map and also the international cooperation. And finally, I will present the expectations for GNSS. So this is my introduction paper. Uh, I had graduated the University of Tokyo for the Doctor of Engineering, and also I have MBA from McGill University in Canada. So I started to work this company from 1998, and still as a consultant of this company. But during that time, I visited to the University of Tokyo for several years. For from 2012 to 2017, I was a project associate professor for CSIS, and now I come back as a leading researcher, and I have some positions for the other universities like Nagoya University and Tokyo City University. And I work for I am a member of SIP ADAS. This is a project for automated driving in Japan. And I am a convener of TC204 for subworking 3.3 location differencing. So let's move on to the first topic, the purpose of this presentation. And this is one. The purpose. I have two purposes for this presentation. The first one is to introduce activity for developing map of automated driving systems in Japan. So car OEMs, system vendors, and automotive vendors are developing a dynamic map. This is a map system for ADS, and the Cross-Ministerial Strategic Innovation Promotion Program, we call it SIP, of Cabinet Office of Japan supports this project. So I will introduce this project first. And the second one is to discuss the expectations for a GNSS from ADS perspective. So I will explain the personal view. Yeah. And also I would like to discuss the possibility, etc. Should I say a little bit louder or it is okay?
Yeah, a little bit. Okay. Okay.
Yeah. I will try to make it a little bit
Okay.
louder. Yeah.
Okay. It's okay now.
Yeah. So I'd like to move on to the next page. So this is the overview of SIP program. The first program had started from 2013, And there are 10 projects are selected at first. And the this one is promote focused end-to-end research and development from basic research to practical application and commercializations. And the total budget for the every year is almost about 50 billion yen. This means the 4,000 billion euro for the years. And actually, this fiscal year is the final year of the first program stage. And we had started the second generation from this uh, year. So now we have the both project, the final stage of the first generation and the start of the second generation. And this is the target goals of automated driving system program. So this is the national goal to reduce the number of actual traffic fatalities to 2,500 over fewer by the end by the year 2018 and create the world of safest road traffic environment by the year of 2020. And also develop some systems and to reduce the accidents. This and this figure shows the participating bodies from the governmental view and also for the some companies combined together. So I don't want to explain this one detail, so I will move on to the next. So this is the scope of SIP ADAS. The first one is to develop and verification of automated driving system. This is the left-hand side. So for the transport system, the driver will start from the recognition of the situation, and the driver will make the judge and operate will done by the drivers. For the recognition part, there are some areas of cooperation, and one of the cooperation area is dynamic map. And we also have research on basic technologies to reduce traffic fatalities and congestions, and also the international cooperation and development. I'd like to explain a dynamic map. So this is the basic concept of dynamic map. The dynamic map is a combined data from the static data to dynamic data, and it is possible to use through the API, and the vehicle and the OEM it's possible to use this one, and also those data are combined with various data and possible to use for the various uses. And this is an example of application. This one is to use for the vehicle position detection. For the sensor data can detect the situation around the vehicle for the LiDAR camera or the laser scanners, and also the GNSS are used. And combined with the high definition 3D map and estimate the position like on the left hand side, right hand side, and to detect the position of vehicle with the compare the sensor data and the 3D map data. And this is the structure and the scope for the equivalation. For the, as I said, the dynamic map has the information for the static part to the dynamic part. But at this moment, we had decided some collaborative area for the static part. In the static part, there are the collaborative area and also the competitive area. but in the SIP project, we had focused for the collaborative area. And for that part, we had decided the 14 features for the basic map supplied by SIP ADAS, and we had tested and created the test data and distribute for the FOT test. So this is an sample explanations. The actual data are used by the vehicle, so usually we don't see like this, but the data are combined like this. There are some the lane information and stop lines and pedestrian crossing and some other features are set as like this. And this is areas for the static map trial. We had created test data over 700 kilometers of the highway in Japan, from the northern part of Tokyo to the very close to Mount Fuji. And this is the actual areas for the inside the 700 kilometers, mainly for the expressway, but we had created some surface way around the 89 kilometers. And this is an explanation for the field operational test. In the test, we will verify the specifications and precision of the map data, and we will try to update and distribute the data, and also we will try to use of dynamic data, not only for the static data. For the field operational test, we had 22 organizations to participate from the Toyota, Nissan, Honda, and also Mercedes-Benz, BMW, and Robert Bosch, and some other OEM-related companies. And this is the schedule for the field operational test. So the static map over 700 kilometers have already provided to the participant. And at the October and November of last year, 20 days and route are already tested. So now we are at the middle of June. So the static data evaluation on the middle of static data evaluation, and we are starting some semi-dynamic tests and to plan to the dynamic data, and also trying to update the static map. So this is the test process for static information updates and delivery. The first, we will study for the use cases and the alignment of matters requiring updates, and study of update rules and information to be added to a high definition 3D map example. So this is an example. So the first, we had distributed 300 kilometers the September last year, and in that data, more than 9,600 road signs, traffic signals, and road marks exist. And after that, just for the 6 months, maybe around 100 of those data are updated. So we need some updates for all that data to refrain for the to through for the actual world. So, and the test field for the dynamic data are still under discussion. So the areas have not decided yet, but we will we will decide in soon. And international cooperation. So there are some activities to create an international cooperation with the international bodies. The first one is to promote for the ISO so promoting the items in ISO-TC2 for working 3, like the items like this and the GTF 5.1 and other related items. And the second part is to promote the dialogue and cooperation with domestic and overseas bodies using SIP ADAS workshop and other opportunities. So there are lots of what is related to the standardization of automated driving. So inside Japan, for example, we have the DMP company and the JAMA. This is an association from the automated makers, and there are some other related organizations. And the overseas, there are some mainly from the European bodies, and we have some alliance with those standardization organizations. And we had created systems inside a project for further discussions. We had created a small discussion group inside the project, and we had decided to formally participating in international standardization activities. It calls OADF, and support is a joint meeting with ISO and OADF. And the next one, I will not explain in detail, but we had already started to making some harmonization with international standardization and other standardizing activities. So this is a figure created with the overseas members, and it is still under discussion, but we had find some overlapping part and some possibilities for the further cooperation activities. So the final part and the expectation for GNSS. First, I'd like to say this is just my personal view. So the lots of opinions exist. So maybe some opinions are not just by myself. So the first one would like to expect is the worldwide use. So as you know, the lots of automotive makers are very widely used global procurement. So they would like to make the systems for the one for the all over the world. So for the GNSS, we would like to use the same system for the not only in Asia but also in other regions. The second one is not only GNSS but also set the control point. So the positioning and also the matching with map database is very important. So connecting lots of data from multiple sources is crucial. So lots of data shall be delivered with accurate position. For the cluster movements shall be took into account like Japan. So for example, the 25 centimeter movement is equal to the width of a tire. So if we compare the data, this year's data and last year's data, and we have some difference, for example, like the 25 centimeters, this means very serious. This may cause a very serious uh, situation for the automated driving in some parts. And the third one is the supplemental methods of positioning for not GNSS area like a tunnel or an under and double deck part. So using the longitude and latitude is very useful, but it is difficult to use such as in a tunnel because it is very difficult to make uh, to make the position. And the supplemental methods to detect the position for those areas are needed. And the last one, the everyone maybe said, and we'd like to have cheaper receivers. So this is all of my presentation. Thank you very much.
Okay, Thank you.
And it is possible to detect some features, and it is possible to connect the position in a map database.
Okay, and you mentioned that some like the accuracy levels and all, but what accuracy do you need or do you expect for autonomous driving? Do you really need 10 centimeter or that, or few centimeter accuracy, or 10 centimeter or meter level accuracy? What is the accuracy level?
Yeah. In Japan, we officially say its accuracy should be less than 25 centimeters for the 1 sigma.
Mm-hmm. So is that possible with the current GNSS system? Is there any some test data?
Not yet.
Not yet.
For the map databases we created for those accuracies.
Mm-hmm. Okay. So maybe GNSS community have to think how they can provide this very high accuracy requirement for the autonomous driving. So it's maybe accuracy and also availability, like in the tunnel, and it's not only tunnel, maybe the overhead, and under the breeze, and under the trees.
Yeah.
And there's another question: what kind of GPS receiver did you use for this method? Did you use any special type of receiver, or how about the Japanese this system, the Madoka or something?
No, we usually use the basic receiver because of the cost limitation. Okay.
So, by the way, what is the cost you expect for such a receiver? Like a $10, or a few dollars, or $100? Few dollars.
Yeah. But there are lots of automotive vehicles in world, so the amount should be very big.
So let me ask you one question about the dynamic map. So as far as I understand that the dynamic map means the map of those things which are in motion, or which are changing with respect to time. For example, the pedestrian or some objects on the street, roadside. I think the mapping of those objects are called the dynamic map. Is this correct?
Yes.
And you mentioned that there are different type of sensors to log this data. So that means when we have automated car, this system, so they will have many different types of sensors.
Exactly.
But when we have so many sensors, so the costs or the system may be also very complex. So I don't know. So could you provide some this type of system architecture, like what type of sensors they have at the moment, and what do you expect in the future?
Actually, we had conceptually defined that to use the dynamic data, but at this moment we had not tested yet. So for the current technology, I think it's very difficult to combine all of moving features for one database or something like that. So that's why we had started from the static part and try to test for the next for the semi-static. We are starting from the bottom.
And there are a few more questions. Could we use Raspberry Pi or Arduino board for these automatic driving embedded systems?
Oh yeah, and for the test vehicle, I think it is possible to use.
Uh-huh.
But for the real market products, those devices will be used more than 10 years or something like that.
Uh-huh. Uh-huh.
So we have to think other aspects.
Okay. And one more. How do we represent lane changing? That's a question in the chat. How do we represent lane changing?
Represent
Yeah.
lane changing. So usually we use the camera to detect the
Uh-huh.
white line in a road and to
Okay.
detect the lane changing.
Oh. So you basically use a camera image as a input source to detect a lane.
Yeah.
But do you also use a GPS coordinates to make some decision on that?
At this moment, I think it's very difficult because of the accuracy.
Ah, okay, okay, yes. So, any more questions from the participants? How about, do you also do some tests or some studies outside of Japan? I mean, in the Asian countries, like, yes.
I heard in China they are very aggressive to use doing those kind of tests, and also in Korea they had they have lots of tests, and also there are European company and in United States also.
Yes, but in Asia, so because we have today
Yeah.
participants from I think from Vietnam and
Mm.
India. So is there any such test in India? So can our participant from India can put something on this? Do you have such ITS auto driving some studies or some tests or something going on in the dynamic map? Do you know? Do you have some background information?
I saw some news. There are some automated driving tests in India.
Okay, okay. Okay, so any more questions? So, okay, probably that's all.
That's fine.
Yeah, I think yes. So we don't have any more questions, and also I don't have any more.
Yeah. And if you find some questions later, all of you can contact me by an email.
Okay, yeah. Okay, thank you very much. So, okay, so let me thank Dr. Nakazo on behalf of all the participants today for his time to give this lecture on a very interesting topic. And we hope to listen to him again in future in similar or other related topics in the automated map, auto driving, and dynamic maps. There are so many things in this field, and probably sometime later we have to discuss how GNSS, what level of accuracy or what level of services GNSS can provide to automated driving. I think this is very related with the GNSS input data. Okay, so thank you very much. And before we close, I just want to let you know about the next webinar that will be on 22nd of June on Friday, next Friday. And we hope to see you, all of you again. And thank you very much.
Yep. Thank you very much.
Yep. Thank
Yep.
you.
Thank you. Bye.